Hey, so this is the Physics 2211 Lab 4 by Yu Chen. So, to introduce the lab, we want to observe the motion of a spring mass system with the mass oscillating in an arc. For procedure, we're going to use Tracker to observe position and then use GlowScript to generate a computational model to predict the object's motion and energy changes. And the purpose or the goal of this lab is we want to determine whether or not the model follows the energy principle. So some useful equations in this lab are going to be the kinetic energy formula, which is just 0.5 times mass times velocity squared, gravitational potential energy, which is mass times gravity times like height. And then spring potential energy, which is 0.5 times K times like the length elongated or compressed squared. Is gravitational force, which is just negative mg. We have the velocity update formula, which is F net times delta t times m plus v I. And we have position update, which is v average times delta t plus ri. So here you can see the changes I made to the glow script. We calculate the L hat, S, all this, calculate kinetic energy, gravitational potential energy, etc., etc. It's all from here. And then, of course, we plugged it into here. So we have, things for F graph, F spring, F net, etc., etc. You can take a look, pause the video. Anyway, so in Tracker, once putting the video that we provided into Tracker, we were given this, in which we can see like the period of oscillation in both the X and the Y direction. And if we compare it, you can see it looks like this. So the most important question from this lab is the energy principle satisfied? As you can see from the graphs, it is. Since no external forces affect the isolated system, the change in energy must be zero. Even though different types of energy are in the system, the graph shows that the total change in energy is constantly zero, and therefore the energy principle is satisfied.